This is TMUA 2021, Paper 1, Question 3. We're given an arithmetic sequence and a convergent geometric sequence, which both have the first term being a half. And we're also told that the sum of the second terms is a half, and the sum of the third term is an 8. We're asked to work out the sum to infinity of the geometric series. Pause the video now and have a go yourself. So what we want to find out the sum to infinity of the geometric series. What is the formula for that? So our goal, which is the geometric series formula, is exactly a, which is the first term, all over 1 minus r. Well, we know a, which is given in the question, which is a half, but we don't know r. So maybe that's what we'll go and try and find. So let's try and put all this information into some maths. So what would be the arithmetic sequence? What would the terms of the arithmetic sequences look like? Well, if we denote d to be the common difference for the arithmetic sequence and r to be the common ratio, we know that the arithmetic series must be of the form half, half plus d, half plus 2d, and so on. Similarly, the geometric series must be of the form half times r plus, and then half times r, and half times r squared, and so on. So this line, the sum of the second terms equals half, precisely means half plus d plus r over 2 is equal to a half. We'll call this equation 1. This statement that the sum of the third terms equals 8 is precisely saying r squared over 2 plus a half plus 2d is exactly 1/8. And we'll call this equation 2. Well, what do we notice here? We know these halves cancel, and so we have d plus r over 2 is equal to 0, which we can simplify to saying d is minus r over 2. Okay, so how does this help us? So we can maybe plug this in to equation 2, because we know r and d must solve both equation 1 and equation 2. So if we do that, we get that half minus 2d, which is minus r, plus 2d, which is minus r, plus a half r squared equals 1/8. We can simplify this down and maybe make it look nice by multiplying both sides by 8. And we get that 4r squared minus 8r plus 3 equals 0. This is a quadratic, and we know how to solve these. We can either factorize this or use the quadratic formula. I decided to factorize it because I could see that you can factorize this as 2r minus 1 and times 2r minus 3 equals 0. This gives us solutions of r equals a half or r equals 3 over 2. So which values of r must we choose? Because there's only one value of r, isn't there? So which one do we choose? Well, because we're told that this sequence is a convergent series, what does that mean? That means that the common ratio has a modulus strictly less than 1 for it to converge. And only r equals a half satisfies this condition. Therefore, that is our r. And so now we just have to plug in what we did before, which was our goal was a over 1 minus r, which is exactly half all over 1 minus half, which is 1. So the answer is G.